Hi, everybody, and thank you, Matt, for the introduction. Today we'll be discussing designing Tekla structure connections using RISAConnection, as you can see. So kind of going a little further in here, let's talk a little bit about RISAConnection. So RISAConnection is a steel connection design program, and we're at version 4.0, which was released here about a few months ago. And RISAConnection will actually integrate right inside of Tekla structures. Version 18 you can see is compatible, 18.1, version 19, and also version 20. So RISAConnection is got several versions here available. The latest version is version 4, and that would be the one that you want to use because it would have all the connections available between the two programs of the latest ones we have. So RISAConnection, we have several different types of connections inside of RISAConnection, and it's important to note that RISAConnection has more than the connections that are supported right now. This link is a newer link, so as we go, we'll be adding more and more connections between the link. Right now, you can see on my screen the supported connections there between the two programs. Our clip angles, these are going to be some basic shear and moment connections. So we have clip angles, end plates, shear tabs, moment plates. We've got the direct weld, the splice, the end plate splice, and then the big new one that we added in this latest version of the link here is going to be the vertical braces. Now, you'll see that we've got the description of the type of connection that is, the clip angle. Right next to that is the number of that parameter inside of Tekla. So Tekla Structures has a connection type 141, and that will be described as a clip angle inside of Tekla Structures. So we'll see that in action coming up here, and I'll demonstrate how to see that. But you can define your connections in Tekla Structures using these code numbers, 141, 144, and that would describe the type of clip angle or end plate that you'll be using. And that would be your Tekla Structures descriptor, and then we'll see that RISAConnection has a descriptor more in words here, so clip angle and end plate. And the link itself has a great tool to be able to connect that number with the clip angle descriptor, so we can see that in action as well. The other big focus I want to show you guys is the vertical braces and how that works in our newest link. So before we get into the link here, let's talk a little bit about the workflow and how it is. So with the link that you can get off is directly free from our website. You can download it from the Tekla page. You just get to our partners page, and you'll be able to download the Tekla Structures link. And what we've got here is the ability it will be just installed directly onto your computer. And what it would do is it would take your Tekla Structures model that you've laid out all of your beams and columns and braces and anything in your steel model there. So you're already built up your entire structure and your geometry. And what we'll do is we'll take those connections that you've assigned. You'll go ahead and put as I mentioned, the type of the connection. So you'll put that 141 or the clip angle. You'll take that. You'll assign all those connections in Tekla Structures. And then you'll take that over to RISAConnection for design. So you can see this green arrow here. What we're doing over in RISAConnection is it's the engineering portion of it. So we're taking all of the forces that you've laid out in the connection, and that's going to be taking over, and you're going to check that connection against the code. So we have some American codes in there. So we have ASD or LRFD. You can do the design and pick that type of code. We've also recently added the Canadian codes. So you can design all of your connection based on the code. The RISAConnection will tell you whether you need more bolts, whether you have any type of failures in your welds, things like that. You can size your connection up or down, however you want to set that for the connection. If there's a need for more strength in that, you can assign that. All of the changes you make in RISAConnection will then go over to Tekla Structures. So it allows you to go ahead and take those modifications that you make over in RISAConnection and bring them back to your Tekla Structures model. The bolts and all that will be adjusted, so if you increase or decrease your number of bolts, the sizes of your welds, all that will be adjusted as you go back over to Tekla Structure. Now this is round trip too, so for example, if you decide to later on make more changes, RISAConnection file will then just be updated based on the more changes you make on the Tekla Structure side. So it's a living file. You can start with an initial design and then keep going from there. It's pretty easy to just keep round tripping as you go. The other thing we have here is we have this whole steel model. So some folks are talking, you'll say, hey, what if I want to design the entire structure, not just the connections? And you can get there from RISA as well. So if you wanted to start your model in RISA 3D, for example, you could take your entire design. So you could design or analyze all your members in RISA 3D. So this is, again, your beams, your columns, your braces, lay out your entire structure in RISA 3D, which is going to be a three-dimensional steel. It has other materials, but what we will be talking about here would be steel. You lay out all of your model, your entire building, run the loads, find all of the forces through those members, do the design of the structure, and then size up the members as needed. And then using what we have is called the CIS2 translator, you would transfer all of those members from RISA 3D, the geometry, the materials, all of that, directly over to Tekla. So you can say, take your entire model from RISA 3D to the Tekla model. Tekla structures is going to be a lot more detail-oriented. RISA 3D is going to be more the engineering portion of it. But you can, in RISA 3D, really pay attention to offsets and how you're going to model. Lots of folks do it more on the Tekla structure side. That's going to be more your detailing package. But it also will be maintained if you do it in the RISA 3D side. We have the steel detailing portion of that, so you can go ahead and assign all of the member cardinal points and the offsets and all of that. So as you take that using the CIS2 translator over to Tekla, then at that point you'd probably dial in all of the detailing, make sure that everything's lined up the way you want it to be, and then you could take it over to RISAConnection to do the connection design. So it kind of feeds in both sides of the program. You've got the whole model side versus the connection side. What we're going to focus today on is going to be more of the Tekla structures going from that model directly to RISAConnection to design the steel connections. So when you do get this link, as I mentioned, you can download it right off of our website. And what you'll see there is once you download it and you'll have Tekla structures installed, that's what we're actually downloading and installing right inside of Tekla structure. And that's going to be installing these 3 buttons. And this is just going to be your 3 buttons that are going to help aid your designing of your connections. I'll go through the specifics of these 3 buttons and what they do in just a second, but you'll notice that'll be what's on the top of your new toolbar. So this will help aid us directly into RISAConnection. You want to have RISAConnection installed on your computer as well. So you'll have this will actually install right inside of Tekla structures, and then it will send it over to RISAConnection. So you'll need to have RISAConnection installed as well on your computer. Some of the connections we're going to add in the future here are let me just mention some of the ones that we'll be bringing in. I mentioned some of the ones we already have, but I want to talk about some of the ones we'll be adding. We'll have some chevron braces. We just added the vertical braces, so I have seen the chevron braces in action. They're almost ready to go for the next version. We'll be adding some further moment connections. We'll be doing some bolted moment end plates. We'll be doing some extended end plates with splices. We've got some flush and extended moment end plates. Shear connections and splice connections, continuing adding some further of these. As I mentioned, RISAConnection has a lot of other connections, so we're now just adding the link between the two, between RISAConnection and Tekla structures. So let me show you guys what we have currently. I'm going to jump right into a model that I've already built. Let's see here. So I'm going to open up here a model that I have going here in Tekla structures. And this is just kind of a simple model, but it helps represent a lot of different types of connections. So when I look at this model here, I can zoom in a little bit and see a lot of the different connections that are already in place. And you'll see here I've got some clip angles. I've got, on the top floor here, I've got some end plates, and I've got some shear tabs. So let me just double click on one of these. So this is going to be our end plate. I'm going to double click on that. So in Tekla structures, you can see that you've got a lot of different information. And Tekla structures is really meant for the detailing. So if people are familiar with how connections are designed here and laid out in Tekla structures, you'll note that there's a lot of different options. So there's a simple picture here, but you can really dial in this connection in here when you're on the Tekla structure side. You can also leave a lot of this over to the RISAConnection side too. So if you just want to place a connection as a placeholder, you know you want an end plate, you know you can just assign that to be this end plate, and then later on you can sort of dial in what sizes you want when you get over to the RISAConnection side. The one big important piece when you're over here, though, is applying those loads. We want to make sure that we get the load from Tekla Structures and then import it over to RISAConnection. So you'll see that I have the Design tab showing, and this Design type here shows us that I need to import here the shear, tension, and moment. So this is just an end plate. I'm just going to apply some shear. I put 40 kips listed here, and this is going to be sent directly over to RISAConnection. So I'm going to say OK, and I can double check. Let's look at a couple other connection types here. I've got a splice connection. I'm going to double click on that splice connection. Again, it shows you the picture, shows you a lot of the different parts. This defaulted here, kind of a big type sized plate, but I'm going to let that go, and we're going to see how well it does when we get over to RISAConnection. The Design tab here is going to be telling us here what the moment and the shear forces are. So this is a really important piece for us over in RISAConnection. This is where we want to check, hey, do these forces work for us? Are they going to be okay are they going to pass code check? So I'm going to say OK. And we'll zoom around a little bit more here. We can see I have a splice in this model, a column-to-column splice. I've got, we mentioned here, the clip angles that are going to be welded and bolted on one side. So maybe we ship those beams and weld it on the beam, and then later on we bolt it to the girder. Now, one thing we can also see is we're going to see that toolbar that got added, and I mentioned that there's 3 buttons at the top that got added into the Tekla structure interface. What I'm going to do is I'm going to say Assign RISAConnection. Click that button there. And what that does is it helps me identify what's going on in here. So if I click on the actual connection itself, it gives me a new box here, and it tells me some information about this connection. So this is a 141 clip angle, and it tells me it's a clip angle connection. That's the RISAConnection name for it, and then that 141 in parentheses, that's the Tekla Structures identification for this connection. For any reason you don't want to export this to RISAConnection, you could check that checkbox. It would be probably rare that if you've put a connection here on this side that you don't want to export it, but maybe there's a reason. So you could say, hey, don't send that over to RISAConnection, and check that checkbox. I'm going to say OK. And we'll zoom back out a little bit and see. So you can find kind of any of these. This will give you a point here for whatever one you're looking at. That was a clip angle. This is an end plate, and it'll help us identify what that is. You could also just double click on that type of connection, and we'll see that 144 listed there as well. But what's nice is it gives you an indicator of what RISAConnection might call that. So I'm going to zoom out a little bit. We have the splices as an idea here. We can see I've got, if I double click on this one, this has got a nice big plate on the top there with my bolted moment connection. It shows you all the different options in here. Again, the design type is really the important piece here for us to get the moment and the shear calculations in there. I'm going to assign a connection. If you're not familiar with using Tekla Structures, we can just quickly see how to assign a connection. So if I click on here, Open the Component Catalog, it allows me to pick up a catalog of different connections in here. So we have 144 selected. I can just type 141 was selected, but let's type 144, and I can see that it pops up with a list here of end plate 144. So I can click on that, and once I've got that, I can then click on Create this current connection. So I'll click on that, and I'm going to click on the girder first, and then the beam. And you can see that it then places a connection there for me. So it's going to be my end plate. And you can continue to do that. So click on that, and it'll allow you to do this sort of as you move around the structure. So it's pretty quick and easy to do that. And then what after we want to do that, the big important piece I mentioned is we've got to get those loads in there. So let's go ahead and click on that design type, and we can see they have the 40 shear there. We can say apply that to it, and then we can double click on this one and make sure we get some design type. And it looks like I have actually my default setup that has the 40 kips in there. So that's kind of already all set for me, and I'm ready to go with this design type, and I see that's already there for me. So it's a great tool for me to continue here. I can kind of lay out all of my connections around the structure, but I want to sort of jump into the back side of the structure. Let's look at some of our vertical braces. These are the newer ones here we've added, so I want to show you kind of some of the different pieces of the vertical connection. So you want to have a connection between the beam and the column. So if I double click on that, you can see here, let's see if I can get that up, 141, there's a clip angle attached to the beam and the column. So we make that kind of a connection separately, and then we make the connection for the vertical brace. So I can double click on that, and you can see the vertical brace has a lot of different options. So it can be quite complex, but you sort of go through and get all your dimensions, and then you can see here as you go to the design tab, that's where we are really interested in that tension force. We're trying to apply a tension force for the brace, and this is what's going to get over to RISAConnection. I'm going to zoom out a little bit, and you can see that all sorts of shapes of plates are supported. So if you come in at a shallow angle versus a real steep angle, all these different types of plates are supported, and you can do things like clip that portion there or make it square, as you see in this gusset plate. I can zoom out a little bit, and you can see I'm doing a lot of different types of connections. So some of these are going to be the wraparound hollow structural steel there, the HSS shape, versus here I've got just an angle attached to it. I'm not extending that HSS out like that. So you have a lot of different options for those, how you're going to make that connection work. Okay, so once we've laid out all of your model and you feel pretty safe in that you've got all of your dimensions in here, you've got your loads in place, what you can then do is take this design connections. So I'm going to click on this design connections at the top. It's an equal sign, and what this does is it's taking us over to RISAConnection. So you can see at the bottom here it says assigning the connections. It's running through all of my connections in the Tekla structure model. It's going to open in the background my RISAConnection program. So that should just launch in just a second once it runs through, and it's going to be grouping them all together here. We see this is sort of our sheet. That one sheet is we're going to come back to. That sheet's going to be a great summary of what happened in the model. So now you'll see that RISAConnection opened up on my screen, and you can see all the different options here in RISAConnection. We have all these different connections that came over, and we've got images for each type of connection. So beam moment plate splice, that's one type of connection. We have a couple of the column moment plate splices. We've got some clip angles. We've got the column to beam direct welds. So all the different types of connections we defined, those are going to be broken up into a group. This is what we call a group. The best way to see this whole grouping idea is the pictures are great. You can just click on a picture and it will open up that connection. So there's only actually one connection in this group. But if you go back here to my Project Explorer, that's on the upper right corner of my screen. And what it does is it breaks down my model into groupings. So if I minimize this Project Explorer, what I see is that I have every single one of these types of connections as broken up into groups. And if I click on the top here, this is the entire project. It shows me all these images of each type of connection. Then I can expand one by one and see what's going on in each group. So this one I mentioned only had one type of connection in it. I only defined one beam to moments plate splice. But some of these have large amount of connections in them. So we can see this one here has three different types of connections, three different connections within that type or group. What we call that is a grouping. And it helps you, that grouping helps you design a large amount of connections all at once. So you can make changes to a large group. Typically in a structure, you're not going to modify individual connections so that they're kind of oddball, because it would be difficult to construct just one-off types of connections. Maybe you will have a situation where you have to do that, but it's more likely that you're going to want to do more of a typical connection for this type of connection. So we kind of group those together in order to make that easy for you. So what do we do once we first get in here? And besides just sort of having the images showing to us, what we really want to do while we're in this program is to check our code check. So what we'll do is we'll go ahead and we'll have a solution for it. So we'll solve the model. And there's a couple different ways you can solve the model. You can solve a connection, a group, or the project. So that we have an equal sign with the C for the connection, a G for the group, and you can see as I hover over it, it tells you that. And what we're going to do is the project. So we're going to solve the entire project. Once we solve the entire project, it gives us a little X for a failure or a check, a green check for a pass. And on the right side, we see the fail and the pass listed out after each one of these types of connections. So what we want to do at that point is kind of investigate and size up. So what I'll do is let's take a quick look at this beam moment plate splice. So it has failed. And what I can see here is that it's giving me a UC, which indicates unity check, and it's giving me 0.7. Now, a unity check, you always want to be under 1.0. That means it would fit. It would be a passing unity check. So this one is actually indicating a passing unity check, but it fails. So that's a strange one, and you'll see this most commonly. The reason why you get this is because there's a geometry problem. So actually the code check, all the numbers ran out okay, but there's something that's causing it to fail. So we'll look at why that is. But let's just quickly take a look at this model on the left side. I can kind of scroll this in and out, see how big and little I want this to be. I can make the screen just by sizing it to the left or the right. And I'm going to see here, so I'm going to look at this model in isometric view. It's a three-dimensional model, and it really gives me a way to look at the model. So if you're looking at this connection, you'll probably see pretty quickly why it's failing. Those bolts are almost falling off of that wide flange. So that flange here we can see is really tight. Nobody would build this like that, right? But one of the things is that just a default connection came over from Tekla structures, and we didn't really consider much about spacing or anything like that compared to the size of the actual beams. So what we'll do, we can go to the two-dimensional view and take a look at that as well. So we have two-dimensional views as well as three-dimensional views. And the 2D view, if we just click on that tab, we see it in 2 dimensions. And you'll see when I'm moving my mouse around, it's sort of hovering over what we're looking at. It's kind of what is like a cursor. It's actually selecting what I'm looking at. So I can hover over dimensions, I can hover over items like the bolts, and it's going to select that for me. So if I click on that bolt there, you'll see on the right side it pops up to the bolt size that we're using right now. So we're using a 3/4 inch bolt, 2 rows with 2 bolts per row. Now I can't see much about why this is not working yet, but I can look at the top view, and we can look down on this structure here on this actual connection, and we see, hey, we're really falling very close to the edge there. And that's probably the problem. But I'm guessing right now. Let's take a look at really why the program says no. And so we go to the Reports tab, and that's the 3rd tab on the left here. And we get to see a full report of what passed and failed and why. And it gives us kind of a rundown as we scroll down here of each check. It's a really powerful tool in such that you can go through every single check the program did. And so we see here what type of check it is. These are the geometry restrictions. We see some of the actual calculations here, left beam shear yield. I've got some rupture, plate rupture. I've got all sorts of different tear out calculations. And this is just your summary of what the required strength was and what was available. And you can go beyond that by clicking on any single one of these connections, these checks, these failure checks. So you just click on it. As you click on it, you see that this is the equation. We list out the equation with the equation number to the right here. We have all of the different parameters that went into that equation, and then you can see here what was the actual strengths of that connection there. So it gives you a really great way to figure out what's going on. You can expand these one at a time. So we can tell you, hey, this was 0.7 was our governing code check. That was probably one of these plate shear rupture that we can see, and we can expand those out, and we see like why that is actually going to 0.7. You can expand all of them, so you can click on expand all, and it shows you every single check. That's a little overwhelming sometimes if you're just sort of weeding through all the different calcs, so I always like to say, hey, collapse all, and just kind of as you click along, you'll see what's going on. Now, what you'll note is the ones that are failing don't have those numbers. So as we expand those, these are just pass and fail. And what it's telling us here is exactly what I thought. We're exceeding the minimum edge distance, so it's failing. So we're allowed to have 1.56 inches, and we are currently exceeding that. So what we'll do here, or excuse me, yeah, so we're going too small on that. So what we're going to do to fix that, I think all of these things we're going to see that, hey, we have a lot of failures there, same 1.56. I see some other ones that have here some bolt bearing failures. One, it can't even do that code check because it's too close to the edge. So what we'll do is I'm going to go back to the two-dimensional view. I'm going to zoom in a bit, and I'm going to see here, okay, so I see that 138 that it was complaining about, and that's that edge distance. So I'm going to tighten up this here. As I click on that 5.5, you'll see on the right side of my screen the flange bolt gauge changes. It highlights up there 5.5. So all I have to do is type. I'm going to type maybe, let's say, a 3.75 in there. As I do that, you'll see that it adjusts for me. I can just push enter or click over here to see. It adjusts the size there for me. It didn't see, it's not adjusting, it's adjusting the number I told it to adjust. And then I can zoom in a little and say, okay, well, now we want to hit that 1.56. That was really the reason why it's failing. So I'm just going to go ahead and say 1.6, just for good measure, a little extra there. And now, just to check this one connection again, I can go up to Solve Current Connections, click the Solve button, and now it passes. So I go back to the reports, and I can see, hey, okay, now it passes. And everything, if I collapse all, everything passes. So this connection is considered good. So you want to go through all of your different types of connections. Let's see, I'm going to do very similar thing here on the moment plate here for the column. Okay, we can see the same problem exists. It's just hanging off that edge. If this was grouped together, this is the same type of connection. We could flip them all at the same time. I'll show you that, how you change a group. But this one here, we can just double check, am I still having that same problem? And yes, I'm exactly the same, very similar numbers. 1.56 is what we're allowed, and we exceeded it here with the 137. It's too small of the edge distance. So just again is going straight to the two-dimensional view. I can go to the front view, and I'm going to make the similar changes that we had before. So 3.75, push enter, and it's as easy as clicking on the side parameter here and saying 1.6, enter, and actually, sorry, it's this one, 1.6, and you see that increases that there for us. So it looks like this is actually a little too big, too small. I must have put in the wrong dimension there. So I'm going to say 3.75. There we go, and it adjusts that for us. So I've got the connection all in three-dimensional view now. We can see that it fits my actual plate, fits my flanges. I'm going to run that connection, and that is all good. The ones that are passing are fine. You can look at some of these passing ones. This one is really undersized. So you can see, hey, that one's a little bit at 0.1. That's kind of small for the code check. We probably are over-designing this one. And so as you see, hey, maybe you want to change the sizes of these connections, both two connections that I'm pretty oversized on. So maybe you want to save some money, you can go ahead and click on the angle, size down the angle, or let's just say, hey, let's look at that weld. That's a pretty, maybe we'll reduce this down to a 3/16. So it's as easy as clicking on the actual weld itself, and you'll see that that highlights the beam weld on the right side. So I just highlight that and make it a 3/16 instead of a 4/16. I can do that on just that one connection, or I can do it on the group of connections. Let me show you that quickly on a group of this connection. So if I click on the header of this name listed out as column beam clip angle, it goes back to the group view, which is the two connections that are both within inside of this group. And I can see here that I can look on the right side and I can see that I want to change that beam weld again. And it tells me that right now it has various sizes because I already changed one. So what I'll tell the program is I really just want to make them all 3/16. And it will then clear out the code check, and I can size that group and see if it passes. It's still very much under code check, but it just shows me how I can continue to size things down as needed. I'm going to expand some of these other different types of checks, and we can take a look around here. So I have a direct weld moment connection, and this shows us here that we have some stiffeners, so I can click on that, and you see the size of the stiffeners and the ability to change things on the stiffeners. Let's look at the code checks on this one. So this has got, if we look here, we can see all the different code checks that were done. We've got a long list here of the different things. We're doing the beam weld shear yield. We've got the beam web shear rupture. All of the information here, again, we can collapse or expand all of these different checks as needed. The other piece I should mention too is that this is telling us we're doing an LRFD design at the top. We're going to be checking on this based on that, load factors there. If you go over to the members tab at top, it tells us what type of member this is, the column and the beam. So everything is sort of a tabular. You can click on the column and the beam. You'll see the different types of members we're using, the components that we're using inside of this connection, the plate, the stiffeners. This is a great way to sort of see the summary of what happens inside of this connection. If you want to make changes, this is more for reporting. If you do want to make changes to that, you can kind of pop over to the right here. And as I mentioned, I really like to be able to make changes just by clicking on the elements you want to change. So click on that weld, click on the plate, and you can make those changes there. I'm going to expand some of these other ones, we can see I have let's see, we have the connection here. This has got a really large plate. So maybe what we can do is size this plate down a little. If I click on that plate there, I can see this is going to be a thickness here, a really large thickness. Let's try to drop that down and see if that works. So if I solve this connection one time here, I can see it actually works without a problem on that moment plate section. So I'm going to just size it. You can continue to size it and see if that makes any difference. But you've got, this is adjusting both the top and the bottom plates. And so the same, now I only did that for one. I could do this separately. I can do it together again as the group is sort of a best practice is to do it as a group. Scroll down here, I can see I have the girder beam clip angle connection. I have all of these are passing. I still have a couple failures, so let's kind of move down to the failure modes here, but I have some beam end plates and all of these look like they're passing with 3 bolts. I'm going to scroll down below that and I'm going to see here I've got a shear tab. These are all sort of large connections. What's going on in here? I've got a couple failures. So let's see, let's look at the one at kind of the worst case. If we look at the 1.8 connection here, this is unity check of 1.8. So something's failing in this one. We can see it's pretty high compared to the others. We look in two-dimensional view, so there's no obvious geometry problems. But if the 1.8 indicates that it's a real code check problem. So when we go to the reports on this one, and we scroll down a bit, I can kind of look at what's going on. So geometry we said is probably okay. I didn't see any problems there, and they're all passing. But we look down here, we have some failures, and I really always like to go to the worst case to see what really made this fail. Maybe we can solve that one and fix ones along the way. So we look at here, there's some bolt shear at the beam is causing us a problem. And you can just look at the equation, see what goes into the equation, and see why that might be. So what are the variables in this equation? Well, number of bolts. So we can easily add, increase the bolts, number of bolts, the area of the bolt size. So kind of easily gives you an idea. Do I want a bigger bolt or do I want to add more bolts? Maybe I need to do both. But what we can quickly do is just pop in some extra bolts and see what that does for us. So I click on the two-dimensional view, and then I click on the bolts, and it pops this on the right side straight to the beam bolts. We can see I'm using a 3/4 inch bolt. So what I'll first do is just increase the number of bolts. Hey, will 4 bolts help this connection? And I'm going to solve it with the 4 bolts. It's still failing. So just double checking, does that still the same failure mechanism? And yes, it is. So it's still the bolt shear at the beam. So maybe I'll increase the size of that bolt and see if that helps us. So you can just sort of size it up. It's still going to give me here, let's see. So I'm still failing on that one. So with 4 bolts, and I have, let's see, I'm going to maybe go to 2 rows. I can see if I can add a row to that. So I'll add another row. I'll maybe add some space in here, so we space this out a bit, and add some more dimensions here. Let's say 1.5. So we kind of bump this out a bit. The whole dimension of this plate, we're going to move this out maybe 5 inches, and we're going to sort of scoot this whole plate out a bit. See if we can kind of get this whole plate to work, and we'll kind of increase the size and see if we, let's see, 6, and maybe need to increase that a bit more. And we can keep moving around the dimensions and see, what works. So now I'm going to say solve that and see if it passes. So we're not quite there yet. It's going to still have some issues. We're so close, though. So you can see maybe we need to increase the bolt size a little bit more. So you just sort of tweak that a little bit more. And these are decisions that you want to make sort of as you're going. You say, hey, what's going to make this better? Oops, looks like I actually went smaller. So what's going to make this size, this connection better? And what's worth it to me for construction? Do I need to continue to add bolts? Do I just to say, hey, I probably need to make this a different connection type? And if you do, then what you can do is move that over to Tekla, back in the Tekla structures model, and reassign it. Maybe this just isn't an adequate type of connection. So you can walk through all that different design decisions as you go. The same thing, I'm going to go here over to the vertical brace diagonal connection. So it looks like all of my connections work out okay, but one of them looks like I have just a slight problem on. So let's take a look at what the connections look like here. So I've got I can see different types of connections that are happening in this vertical. This one's a real complex connection. What you'll note for vertical braces here is that you have a lot of different connection points. If we look at this in two-dimensional view, there's a ton of dimensions. There's a ton of going on. And in the report, when we look over at the report, we can see really when we first look at what's happening in this connection, this is a summary. It's going to show us what's happening in that connection at each connection point. So beam to column, there's a connection. The top gusset to beam, there's a connection. The bottom gusset to beam, there's a connection. And each one is checked individually here. So we're seeing what's happening at each connection point. You'll see as you scroll around here. So are we going from the beam to, to the column? That's going to be this connection. The gusset here to the brace, all of that. So different pieces of this connection. So when we see a failure here, we see that we have a top gusset brace connection. The brace tensile ruptures. It's just going 9.99. Whenever a program goes to this real high number, it's just an indicator that we just can't even get into the code check. That's not even a check at that point. There's just not a fundamental problem. So what we can do is we can take a look at the top gusset to brace, which is at the top here. So you'll see each single connection is going to have a breakdown of its connections. So that was just a summary. As you look to the top gusset to beam, we wanted top gusset to brace. That was what has been failing, and it was the brace tensile rupture. So you can see we just have sort of a big problem even getting into this calculation. The shear lag factor, everything is just sort of dropping down to 0 for us. Let's take a look. This is going to be what we said here is the top gusset to brace. So what I can look at here is it looks like this is so short compared to the rest of the structure down at the bottom. So I can pick on that brace there, and I make that entire length of that brace here, that weld length longer, and see if we can get that a little bit more in line. Let's see, actually we can probably continue to grow that a bit. So that's an 8-inch weld now. So I moved that brace all the way down real close to, I can probably even go a little farther, but let's see how that goes. Run that connection, and then it comes in now in place. So we go back to the reports, and we see here now all of a sudden there's no problem. So it's just that I had sort of to grow the tube a little bit farther as I went down the structure. You see that now this will actually get adjusted when we get back over to Tekla structures. So any changes I make like that, the beams, actually increasing the size of this tube, but even all the connection types, those are really what you're, increasing of the bolts, the welds, all of that, that will get adjusted once we move back over. So I'm going to say I'm kind of at the point where, all right, I've gotten to a good stopping point. I'm going to say let's save this model. I'm going to save the model, and now this is a RISA connection model that can live on its own. So in this case, I was demonstrating me being the engineer. I'm also having Tekla structures on my computer, so I'm sort of the double duty. I'm doing the design of the structure in Tekla structures, and I'm laying out all of the locations and all of Tekla structures information, as well as doing the RISA connection model. That doesn't have to be the way you do it. So if you weren't going to be doing both of those tasks, you could have just taken it right over to RISA connection, saved it, didn't make any changes to that model, send it to your engineer. Your engineer would run through all of what I just did, make the needed changes to it, and then send it back to you. All you need to do at that point is just replace the file that you have. So if you've done no changes to it and you're just sent out like what we call, a starter model, they would then be able to send you a finished design model, and you would just place it right into the folder that was saved in. So if I look in my computer, I have I have just my C directory, and then I go to my Tekla structures folder, and that's where all of my models are being held. So Tekla webinar here, this one is right here. I open up this one, and I will see that there's going to be some RCN files in here. And that's going to be, this is one we just did today, this Tekla webinar version 4 RCN. That's the one, and I just saved it a couple minutes ago. So that would be the one that you would have your engineer, you would have him send you this back to you, and you would override this model. And then when you bring that back, you'd open it up and bring it back over to your model using here, so you can export the connection results to Tekla. The other thing I just want to show you before we leave RISA Connection too is that you can print out a report. So you can print the results of what your model is here in RISA Connection based on a lot of different things. So we saw that you can do two-dimensional views, you can do three-dimensional views. There's a lot of things you can even see in those reports. You can see it fully expanded or just a collapsed view. That was when I expanded all of the calculations, and or you could just say, hey, I just want an overview. And you can send in all of your connection types or maybe just the ones that were the governing ones. So there's going to be those connections that are going to be the ones that are going to govern for the entire grouping. So maybe you just want to send over those. And you make those decisions about what you want to see. Do you want to see all of the parameters or just a few of these parameters? And you can send that out directly to a report. When it sends the report, then you can print that out. And so, you know, anybody who has a RISA connection model can just generate this report. So that's a great way to get an overview. One of the other pieces, though, is we'll see that once we get over to the Tekla structure model, we have another summary there. So that's a great way to see the summary of what happened over here as well. So I'm going to click this button that says Export Connection Results to Tekla, and it's going to do is send that directly back over. It's opening the summary sheet we saw on the way back. From Tekla Structures over to RISA Connection, we saw it put all the information in here. What it's doing right now is it's laying out the results of this information. So it's laying out the pass and the fail. It's telling the program in Tekla Structures what passed and failed. And then when we go over here and we get back into Tekla, let's see, I'm going to show this on top here. You can expand this and see the pass and the fail. And I'm going to just open this up a bit here so you can see. It gives us the code checks. And this is a true summary. So this is giving us, hey, this passed and failed. There's no expansion in here. That's because you're going to have, when you expand it, you're going to all the engineer calcs, all that stuff. If you want that, that's over in the RISA connection model. But this gives you a nice just pass and fail, what happened, and then a nice overview. So you can see each of the different types of connections and what happened in there. If there's any errors or warnings, what happened, it'll give you listed in here as well. So it gives you a nice wrap-up of what happened. The other last thing before we leave this summary I want to show you is this mapping file editor. If you click on that, this tool here just helps us, and it's just going to load for a second. A mapping file allows you to import different types of shapes from your Tekla model into RISA Connection. So for any reason here that you have a shape that doesn't have the same exact name that we have in RISA 3D, this would be a great way to map the two together. And RISA 3D and RISA Connection share their database. So those two types of, that AISC database that we're using here on the RISA side may not match exactly the title that you use over here on the Tekla side. So if I scroll down, a good example of what might be different, and we've filled out most of this mapping file, but maybe a shape kind of pops up that you want to see it's a little different, would be an L shape here, or an angle. So RISA has its own designation for these types of angles, and Tekla would have their own designation for that. So they're not one-to-one. So this mapping file helps tell the programs what an L 2.5 by 1.5 by a quarter is in Tekla structures versus what it is in RISA. And you can see we just use a little different nomenclature there. You can, map this just by telling the program. And the other piece, too, this helps you as well as the different databases. Not only do we have just AISC, but we have a lot of different types of databases. So maybe you're not using the American codes and the American databases, and you can map those together. So I'm going to close that. And let's take a look at our model. So all of your Tekla structure model has now been updated. So what we can see is we can scroll a bit around, and I think one of the big things we did, I'm trying to look for the ones we adjusted, but we sized different things, we sized the plates. The big one we saw is that connection of that splice there. We sized those plates so now they fit. That was a big thing. And then we did some of the vertical brace connection design. I think we increased some of the HSS shapes so that they would be a little bit tighter, and I can see that that's happening here in this corner. What I can also do, though, is I can continue to work on the model. So that's a common case where you're going to be in Tekla Structures, you've got your initial design, you went over to RISA Connection, you did that design, and then now, as life goes on, things change in the model. It's not just a one and done typically. So maybe you need to go ahead and make some changes. You can do any type of changes to the model, and we can take it back to RISAConnection and check it again. And a big thing, maybe somebody decides, hey, we can't do any in-house welding that you described here, and so we're going to have to change all of your clip angles, and they're not going to be welded on that one side. Then we want them both bolted. So you can go ahead and go into your connection there, click on that bolts description, and instead of having it welded on one side, we can change it to be just a bolt connection. Make that modification. We can change that. We can go ahead and change a couple of these and say, so just for, let's see here, just for time's sake, I'm going to just change a couple. Go to the bolts and change that to be, instead of welded, we're going to say it's going to be a bolt connection. And then I'm going to, let's see, the other piece you can do, so maybe we said, hey, these beams are just too big. We're going to kind of size beams down. Whatever you do to these connections, you can go ahead and make any changes that you want. So the size of the connection, whatever's framing in, we can make changes to the size of the bolts, or anything you need to make. Even the geometry, if things just got shorter by an inch, all of those are the things that are real important. In the detailing model, that's what's going to be erected. So that's important for you to get that very accurate. Once you've done the legwork there on the RISAConnection side, probably most of these things are just going to be small tweaks. They're not really going to be big problems. And so it's just easy for you to say, okay, once you got your design initially done, you just can say save that model, and you can just send it right back over to RISAConnection. So I can just save the model again and then just go ahead and use the equal sign there. It's going to go right back into RISAConnection. So we have assumed we closed RISAConnection. But you can have kept it open. It would have just told us to close it a second there. But what would happen now is I'm going to say, let's say this is weeks later. I want to just double check that some of these changes I made are going to work. So I can go ahead and see that it's going to launch RISAConnection behind the scenes, and it opens on my screen. And now I should see some of these different modeling here. So I now have some clip angles that are going to be bolted. I made two connections that are bolted. I can then check that, and they fail. So there are some failure problems in here, and we can see again those failures are going to be geometry failures. Looks like I have some problems. I'm just doing the same exact problem there. So probably what you do most likely is lay out some better rules over on your Tekla structures so you wouldn't kind of have these failures in your edge distance. But again, so easy to make that quick change. Okay, so we know we need to hit the edge distance a little bit better. Let's increase the size of this clip angle, and let's see, here we're going to make these a little bit shorter. So maybe make these 2 inches, and we need to make this about 1.56, at least let's say 1.6, and we know we definitely need to make this a little bit bigger. So let's get 3.5, and we're going to make this actual here about 3.5, and we can go ahead and increase this one to maybe a 2 inch, and we should be able to get that to go to 2 inches, or at least maybe 1.6. And let's go down, and let's see here. So it should be letting me do a little bit, and then we can go to our front view and see if everything works. And you can continue to adjust that. So it looks like we're still almost making it, but we're not quite there. You quickly make those changes to this on RISAConnection side. So you can go pop in, make sure you are passing. So it looks like we're still barely making our edge distance, but you can make those quick changes over there and send it back. Now, I've just checked that one connection. If you check the entire project, you'll see that everything else was preserved. So you go and say, okay, it looks like I left some of those out as failures. I can continue to work on them. Doesn't mean I have to do that right at the same time I was doing the connections at that previous section. You can continue to come back in here and make more changes and then send them back. As you make those more changes, you just push the Save button one more time and export it right back over to Tekla structure. So you say the export connections results to Tekla, and then we see it runs through that summary one more time, and I get to go back to the Tekla structure model. It's launching in the background here, and as it's going, it's sizing up everything that we have in that model. So we can see it's going through each connection and updating it one more time. So round trip, you just continue to go as much as you need and as many changes as you need. There's probably no reason ever to start over, but if there's something you say, hey, I just want to start over from scratch, all you need to do is just get rid of that file that exists there with the same exact name as the name of your Tekla structures model, and then you could be started over. But it's probably just as easy just to put it right on top of each other. So I mentioned that we were going to be adding new connections. We were working hard on this connection between Tekla structures and RISAConnection. The link has been updated a lot within the last couple of years here. It's a pretty new link, as I mentioned. So what we're doing is continually adding more and more connection types. We're adding based on user requests and what we see here, high demand between what people are using in RISAConnection and what people are using in Tekla structures. So on my screen is some of the new ones I mentioned earlier, but you'll just continue to see this as increase as we go. And I sort of pass it back to, if there's any additional questions, we'll be here, and I will pass this back to Matt. Thank you so much for everybody's attention.
Thank you, Debbie, and thank you everyone for your participation in today's webinar using the RISA Tekla link with vertical braces.